Well, g'day and welcome back to part 2 of building the Stuart number 8 mill engine. I've called this series the whole shebang because I do want to show the entire construction of this little engine. I'm a bit worried it's going to end up being more episodes than Breaking Bad, but hey, what can you do? In this part I'm going to show you how to machine the slots for the bearing brasses, also drilling the stud holes for the bearing caps and the hold down bolt positions which holds the engine bed to the engine base. Just for reference, I'm using a Sieg X3 milling machine which has been converted to CNC. I've done a number of modifications on this machine which include filling the column with epoxy granite, which has helped to increase its rigidity, but at the end of the day this is a very light milling machine. It does struggle to produce accurate results, mainly through flexing in the column. I have fitted this machine with double ball nuts, which improved its accuracy slightly, and certainly filling the column with epoxy granite has stopped some of the twisting and the rocking that used to happen with the cutter, especially when it was machining steel. What I intend to do today is to get this casting aligned accurately with the x-axis of the mill, and once I've done that I'll secure this down accurately to the milling machine bed. We're going to have a look at how we're going to set the origin for all of the machining processes. The origin is going to be right at the very center of this machine's circular boss. Once I have that, all of the rest of the geometry is going to be relative to that point. I use Corel Draw to do all of my 2D CAD drawing, and I use Kanban to create the tool paths, and Mach 3 to do the actual machining process. So we'll have a look at that and show you how to get this aligned, and then we're going to have a go at doing this machined section here for the bearing brasses first, because I figure that's probably the most important part. Okay, let's see how we go. So with the base set up on the table of the mill, and I've squared across this face here using a dial indicator, the next job is to get a datum point from this face here, which is really the anchor for all of the geometry that I need to machine after this point. So I'm using a homemade touch probe here to give me a location against that face, and then I'll get a reference point on this outside diameter, and I'll be able to offset to find the center. So let's just go ahead and use the probe now to locate that surface. Okay, so it's with Mach 3, it just simply moves the table until it's in contact with the probe. It stops at that point. You can zero the X at that point, and my probe diameter is 6 millimeters, so I can use that to offset another 3 millimeters to find the center of the probe over the surface there. So I'll go ahead and do that, and then we'll probe this outside diameter here. So I've lifted up the probe, and what I'll do now is just use an MDI or manual data input to move the probe 3 millimeters from that position where it is now. So we're just going to do a G0 X minus 3 and 0 again at that point. Okay, so now having locked that in, we can get a position here. Okay, so we're located just a little bit to the left of the diameter there. So once again, using Mach 3, we're going to move across Y in the positive direction. Okay, so stop there. So we're going to zero Y. Okay, now I can work out my offset from that surface. So it's going to be 3 millimeters plus whatever the radius is there. Okay, so that now puts me directly over the top of that diameter there. I've already got my offset against this flat surface here. So the next step is when I put my cutter in, I'm going to touch the cutter off against this top surface here, and that's going to become my offset reference point for the very center of the bore. So we'll get all that set up, ready to go, and then we're going to have a go at machining these bearing housings. Alright, so I'm using a 10mm 4-flute end mill, and we're going to bring this down almost touching that diameter there, and then I'll go the rest of the way with the quill. So let's go ahead and do that. It's just so I can see what I'm doing here. So I'm just going to come down the rest of the way now and lock the quill. And I've got just a piece of feeler stock there just to protect that surface. So I'm going to zero out the Z, and I'll just come up. Okay, so now I've got my known location here. I can offset to find the very center of the bore. So this is going to become the origin for all my machining processes after this point. I don't usually home this machine because I do mainly single setups. I usually get my part on the table, and then I do all of my referencing on the part because I rarely reuse a setup. Well, in theory that surface now should be the correct height above the base and a correct height above the origin point. I'm sure you heard that my machine struggles a bit with cast iron, especially given the state of this cutter, but yeah, it's done a pretty good job. It's not bad, just needs a touch with the file. So having got that to the correct height, I'm now going to try doing this pocket for the bearing brasses themselves, and this is just going to be, and I'm machining about 0.2 of a millimeter undersize, and I'll check it, and if necessary I'll do a clean-up pass, like a climb milling pass to finish. Alright, well that sounded absolutely horrible, but it's done it. It's machined that out quite well. I'm just going to run a caliper on that just to see how close to ½ an inch I am. If it's really close, I'm just going to finish it by filing. If not, we'll run a climb mill pass to finish up. Okay, it's come out at about 12.4. It's a bit hard to show you, but it's showing 12.4 in the center of the slot. So according to my CAD G-code, that should have come out at 12.6, but I'd say that there's been a fair amount of flexing of that cutter off that face there. So we'll run the climb mill pass and see if we can get it close to, say, 12.7. I can machine the bearing brasses to fit the slot. It'd be a lot easier than trying to make the slot fit the bearing brasses. So if we struggle a bit, I can compensate that way. I've just checked that with a bore gauge and a micrometer, and it's come out at about 12.47, and that last climb milling pass I decided to go about 0.1 undersize. So let's see, no, that's showing 12.6, 12.63. You know what, I'm just going to leave it like that. I'm going to dress that with a file just to take off the machining marks, and I reckon we'll be close to size. So let's leave it there, and what we're going to do now is drill these fixing holes for the bearing caps. Okay, so I swapped out my milling chuck for a Jacob's chuck. I've got a centre drill in the chuck, and I've set up a G-code that's going to drill the 4 holes for the studs which hold down the bearing caps. And my G-code is really just a drill positioning system. So I'm not bothered about having the Z-axis motor drive the drill bit into the stock. I'm just going to position the drill bit where I want it, and I'm going to use my Quill and manually drill the holes, mainly because I don't want to risk breaking a drill bit in this stock, and really it's a one-off operation. If I was going to make 100 of these, yes, I'd probably set up a G-code that did everything automatically and I could just let it run. But I don't think it's worth the risk when you're doing prototype work, which is essentially what I'm doing, to drill material. And if you get it wrong, if you get the feed rate wrong, get the speed of the drill bit wrong, yes, you will break it, and then it's a disaster. So this is my first drill position. So what I'll do now is swap out the correct size drill bit for tapping. Okay, so I've swapped out here for the correct tapping size for a 5BA thread, and I think it's number 39 drill bit. The drawing showed that the drill hole has to be 5/32 of an inch deep, which is roughly 4 millimeters. So it's just going to traverse around the 4 positions, and I'll drill 4 millimeters, which I'll set on my Quill, and then we'll have a go at starting the tap thread. Okay, so that's got my drilled holes. My centre drill that I used started that hole a little bit bigger than the tapping size here, but that's a good thing, because that'll give the tap a bit of a lead in. So I'm going to swap out now for the tap, and we're just going to start the threads, and I'll finish them by hand. Once again, it's not worth the risk of driving a tap that small under power into a hole that size, and if it breaks, you know, I've only got the one casting. Okay, so I've got my 5BA tap just set in the chuck there now, and what I'm going to do is just lower the Quill until that tap is engaged in the hole there, and I'm just going to give it a few turns to get it going. And the advantage with this is that you get this repeatability, so every time I advance the G-code it goes to the new hole. I know it's lined up within, say, 1/100 of a millimeter, and the tap is held perpendicular to the surface that I'm tapping, and I can sort of feel how much resistance I've got in the tap there. I'm actually just going to take this out of gear, and then I can back that out. So that's begun the thread. I'll finish that by hand. I'd prefer to do it that way so I get a better feel for what's going on. And we're just going to advance around the holes one at a time. And remember, this is not production work. This is one-off single operation work, and that's why I'm not taking full advantage of what CNC can do here. Okay, so that's got my threaded holes started now, and they look lovely and accurate, and that's what I love about this CNC process, is the repeatability and the accuracy you can build into the process. If I was doing this the old way, by bluing this and then marking center lines, center punching, it's not going to be as accurate, not with my eyes anyway. So what we're going to do now is going to drill the 4 holes for holding this down to the base of the engine, and these are going to be through holes, so I'm not going to drill all the way through. I'm just going to mark it with a center drill, and I'll finish off on the drilling machine. I was going to stop this. I don't know if you can see it, I'll zoom in, but there's a little dimple in the casting which I'm guessing was put there deliberately to show you where the center of that drilled hole should be, and the drill bit is lining up with that almost perfectly, and that just shows you that the NC code is accurate and I can trust it to do the other holes. So if I bring that drill bit down, it's right on that dimple. Why don't I just zoom in? So there's the drill bit, and it's right on that mark. So I'm sort of feeling confident that I've got that right. Alrighty, so that's taken care of all of the most important machining processes on that base casting now. So the only thing remaining to do is drill these through holes all the way through. Might spot face those to finish them off, and we're going to finish tapping these holes, and there's a bit of drilling to do at the other end of the casting, but we're pretty much done. So I'll just take this off. Okay, so these look nice and concentric here, so I'm happy with that, and these ones certainly are right in the middle of the features. But there we go, that bit's done. Well, what you didn't see me do off camera was clamp the engine bed down to the base, and I spotted through the 4 mounting holes to enable me to drill through the base and tap that 5BA. Surprisingly, the kit came with all of the fasteners that I need to put it together. So there are a set of studs that allow me to hold these 2 parts together, and of course nuts to clamp that all down. And I've just done a trial fit to see if that's okay, and it's fine. So the process for aligning this wasn't terribly important. All I did was clamp it in place, and I just went around with a depth gauge and I just measured and compared that both sides, because none of this is machined, so you're just relying on the dimensions of the castings to get that right. So I can now clamp all that together, and I was able to also screw this engine bed down to a piece of timber, and I've gone around and just fettled the casting, so I removed some of the imperfections in the casting. Still needs a bit of work to be done. I'm not real happy with the shape of these lugs here, so I might need to do some work on those. The sockets for the bearings, or the housings for the bearings, came out a little bit undersized, and I realised afterwards that the finish inside here wasn't the best. Where the end mill broke through, it was a little bit undersized on the outside, and it was about right in the middle. So I just put a file across that surface, and I just worked on it in the vise until I got that to dimension. The piece of brass extrusion that's supplied in the kit for the bearings is already finished to a width here of 1/2 inch, a little bit over it was. It's already finished to width this way, and the thickness of the flange at the top there is 5/32, give or take. The only dimension that's oversized is this dimension across the flat here, and it's supposed to be 1/2 inch. It's a little bit more than that. So the next thing I need to do is to figure out how to make these bearings. They had to be drilled through on this end face here. A sort of a spigot or a lug has got to be formed on the outside of that, and of course it's got to be drilled through for the studs to hold the bearing in place. The most critical thing is that when it's assembled, that the crankshaft can lie across that housing there, absolutely perpendicular to the axis of the engine, and also parallel to the base of the engine. So if I get this wrong, if I drill these holes off center, or if they're not parallel, I'm in real trouble. And what I'm starting to think is that I'll finish the bearings, bolt in place, and then I'll run a reamer through when I'm all done. The brass extrusion itself is sort of fitting in there pretty well at the moment. That's more or less the fit that I want. There's very little shake in that. Probably needs a little bit of touching up when I'm done. So at this stage I'm pretty happy, but certainly working on those bearings is going to be the next part. Well, you wouldn't believe it, but the probe that I was using was actually bent. It was out by about 0.1 of a millimeter as it rotated around its axis. So I'm going to go old school and use one of these edge finders. Okay, so as near as I can tell, that's center of my crankshaft bore. So I'm going to drill there, but I'm only going to drill through halfway, and then I'll flip it over, drill through halfway the other way, and then I'm going to make a mandrel to mount this on, and then I'll do the rest of the machining around that mandrel. Okay, here we go. Okay, so my crankshaft diameter is 5/16 of an inch. That's about 7.93 something or other, and this is a 7.8 millimeter drill bit. So it's going to leave me a little bit undersized, so I can run the reamer back through later on, and I'll turn my mandrel to be a snug fit for this, whatever this diameter is. Should be about 7.8. So I'm drilling the full depth of the bearing, which is 5/8 of an inch, so we'll go to 18 millimeters deep. And when I cut that off, that should expose the hole on the other side. Okay, so that's 18 hole looks pretty good. So I'm going to turn this stock over and do the same thing on the other side. In theory, it should all line up if I'm pushing it up against this parallel. Okay, so there's my bearing stock done. So we're going to make a mandrel now to mount these on the lathe, and then I can machine that face, the spigot that goes on the end of the bearing face. I can part it off to length and all that sort of stuff. So over to the lathe next. Let's hope I got those holes in the middle. So what you didn't see me do yesterday was I cut the brass bearing stock in half. These are the drill holes that I already put in on the CNC mill, and this is the sawn face on the back. So what I'm going to do next is to put this in the, I have already machined one face in a 4-jaw chuck on the lathe, and I'll reverse that and machine the other face until I get back to the required thickness, which is 5/8 of an inch. So having done that, I need to then mount this on a mandrel and machine away the face and leave behind just a circular boss, which is the same width as the bearing journal itself, which is 1/2 inch. So this one is already machined both ends, and that's the correct thickness there of 5/8 of an inch. So I've already scribed a line here at 5/8 of an inch from the machined face, and I'm just popping this into a 4-jaw chuck, and I'm not particularly bothered about centering this stock in the chuck. This is just a facing operation I'm carrying out here. Alright, because I'm a complete idiot, I forgot to turn the camera on when I machined the other side of this brass here, so that's lost forever. I can't go back in time and do it again, but I'm sure you've all seen people machine something to length before. So what I need to do now is to make a mandrel to mount these bearing brasses on. Right, so that's working. What I'll do now is just machine down this washer because it's bigger than the diameter of the boss that I need to leave on the brass. So let's just clean this up. Okay, so the setup that I have here is just an ordinary high-speed steel tool with a fairly large nose radius, and I pushed the tip of the tool in against the stock and zeroed my DRO there. I've got to machine a circular boss on both sides of this brass blank. It's got to wind up being 1/2 inch diameter and 1/8 of an inch deep from the already machined surface. So let's give that a whirl, see what happens. Okay, so that's both sides of that bearing machined now, and I just checked before, and despite my best efforts, this circular boss is not precisely in the center of the section which forms the bearing shell itself. I'm thinking it's about 0.0, I don't know, maybe 0.1 of a millimeter out. Is it going to affect the accuracy of the finished engine? I don't know. We'll put it together and we'll run a reamer through the two bearings, and we'll just see how closely aligned we are. This does need to be chamfered, and the drawings show that there's a chamfer on the inside of one surface of the bearing opening, but I'll wait until I get this all bolted down and reamed before I do that. Okay, so this distance here needs to be brought to size, and then we'll try it in the casting which forms the bed of the engine. These bearing brasses are designed to fit into this 1/2 inch wide slot, but as it's supplied it's a little bit oversized, and I'm not sure, but it could be that makers were given the option of actually producing a split bearing. The drawings don't show that. The drawing just shows a one-piece bearing, so that's how I'm going to machine these. So what has to happen now is we need to machine the total height of the bearing down until it fits into the hole of the bearing housing, with the top plate touching the top surface of the bearing mount. So I checked the drawings. It appears there's an error in the drawings, but clearly the correct fit would be the depth of the slot less couple of thou, just to give it clearance. So that's what I'm going to do. I'm just mounting these in the device, sitting on a parallel, and although I've marked the depth of the machining, I'm just going to use the DRO to do this. Okay. Alright, it's got a few burrs on it, as you can see. It's not very clean. This is the same milling cutter I used to do the cast iron base, and I believe any machine tools you use for brass you should just use only on brass. The minute you touch them on steel or cast iron, they are no longer sharp enough to give you a clean cut, but that'll clean up okay. I'll just give it a light filing and some sanding on emery. Well, that's the finished bearing brasses in place now, and you can see there's a slight gap underneath there, which is the clearance, so that when we bolt these down with the studs and the nuts, it's actually clamping the top of the bearing to the top of the bed, and it shouldn't be binding underneath here. So the next challenge is going to be to bore the holes for the studs. And if I had any brains, I would have done this job first and then spotted through the bearing into the cast iron base. But you may recall that I got all clever and I drilled and tapped the cast iron first while it was on the CNC machine, thinking that that would allow me to get all of that process done in one hit. Okay, so I've just checked the drawings. We need a 5BA tapping size hole right in the centre here, and then 30 and 30 seconds either side of centre we're drilling for a 5BA clearance hole. So I'm just going to centre drill everything first. I'm just using manual data input to get my hole centres. Alright, so it's going to change out my drill now for the 5BA clearance hole, which is the number 30. Okay, this hole needs to be tapping size for 5BA. And while we're here we might as well get that thread started too. Okay, so that's that one done. The other one's going to be just the same, so I won't show you that. Let's just see whether we're even close to getting this to fit. Well, I just put the 5BA studs in their respective holes, and I fitted the oil cup to the tapped 5BA hole in the centre of the bearing. And I guess the first thing we should check is that the hole centres are right, and that looks good to me. The real test is, will it go in the other way? Well, it's a bit on the tight side, so what I can do is just ease these holes out a little bit, just give me a little bit of clearance. But I reckon if I put the nuts and a washer on there and tighten that down, that would fit. So let's go ahead and get the other one done, and then we'll bolt the bearings in place and ream everything, and then we should be good to go with the crankshaft. Okay, I just did a little bit of dressing. These sharp edges on the tops of the bearing housings were a little bit too sharp, so I've just chamfered those lightly, and I've checked the fit of the bearing brasses in their sockets now, and it's all going in nicely. I've put the oil cups into their threaded holes, so with the studs in place now I can bolt down those bearing brasses and then run a reamer right through. And after all the nice things I said about Stuart Turner and their casting kits, buggers shortchanged me one 5BA stud. I've searched everywhere and can't find it, so I'm just going to use a 5BA bolt temporarily, and I'll have to make a stud later on. And they're a pain to make too. Alright, so just put my one odd bolt in there for now. And what I will actually number, or stamp a number or engrave a number into each one of these bearing brasses so they go back the same way every time. I mean, if your machining was perfect, you wouldn't need to worry about it. I know mine's far from being perfect. Okay, so with those, they're nicely seated down on the top of the cast iron there now. So I've got a 5/16 inch reamer, and we're just going to run that through. Now I can see that's taking a few nice little shavings out there, so that's good. Okay, so that's nice. So the next step is to machine the crankshaft and the flywheel. But I'm going to leave this for now. I reckon we've done enough for this video. So in the next episode we'll try and get that end of the engine finished. I'm not looking forward to doing the crankshaft. That's going to be one of those little exercises that's fraught with danger. So much to go wrong. Flywheel I'm happy with, I can do that. Okay, so for now, thanks for watching.